percentages, you can skip that step of having to get the percentages because it's given to you already. Okay.
Okay.
Do you know how many degrees are in a whole circle?
360.
Right, 360. And do you know how to convert 25% to a decimal?
Not on the. Oh, speaking of that, I also finally got the TI graphing calculator,
Oh,
the
nice.
Texas Instrument.
Okay.
So no, I don't know how to do that.
Okay. Anytime you have a whole number and you want to convert it to a percentage, you just divide by 100. So if you take 25 and you divide it by 100, what do you get?
0.25.
Right. And you're multiplying it by 360 degrees. So multiply that by 360. Okay.
90.
So natural gas in number 2 is going to be 90 degrees of your circle. It's going to be 1/4 of your entire circle. Okay.
Okay.
Now go ahead and convert the rest of these measures to degrees. And then if you still need some help with the pie chart, we can go from there. All right. While I talk to Giovanna for a minute. Giovanna, what can I do for you today?
So I got for homework 3.1, I got my answers for 12, 13, well, 12 and 13. And I noticed that the answers are technically right, but it seems that on the answer key I had to move over the decimal point. So I was confused on that part.
Okay,
so,
sure, we can look at it. Let me see if I have that one downloaded. I think 3.1 might be. You said 3.1 and 3.2 both, or just 3.1?
Yeah, just 3.1, and then I had another one on 3.2.
Okay, here is, I don't know if I'm, let me see if I'm sharing that. Am I? Yeah, I am. Okay, so here's 3.1, right? And what number are you talking about?
Number 12 and number 13.
12 and 13. All right, let's take a look here. 12 is find the weighted mean of 3 models of automobiles sold. The number and price of each model are given. All right, so talk to me about what you did here.
Okay, so what I did weighted the weighted mean formula.
Okay.
So I did X bar equals 10,000 times 8.
Okay.
Plus 12,000 times 10.
Perfect.
Plus 8,000 times 12.
All
and
right.
Then on the bottom, I added my W's and I got 30,000.
And so you divided by?
I divided by 30,000.
The weighted mean price, okay?
Yeah.
So the weighted mean price of the models, right? Well, yeah. So what did you end up with when you did that?
For my top, I got a total of 296,000, and then for my bottom, I got 30,000. I divided that, and then I got 9.866667.
And you were supposed to get, okay, now, okay, I think what happened to you here is that when you do weighted means, okay, let me go back, because you're like, I can see why you think you're off here. It took me a minute to see this, but so you had 10, let me see if I can bring up the calculator here so I can show you this. Give the calculator a minute to pop up because it's a little tired, I think. All right, so here's our calculator, right? So you said you did 8 times, can you give me the numbers again? So I don't have to keep flipping the screen.
Okay, you want the numbers for the formula, right?
Right, so at the top you had what?
On the top, I did 10,000 times 8.
Okay, 8 times 10,000 plus
Plus 12,000 times 10.
12,000 times 10. And then
And then 8,000 times 12.
8,000 times 12. Okay, so that gives you, whoops, helps if I put some zeros behind that, right? That would be better. 8,000 times 12. So if I put that in correctly, I think I did. We'll see right now. 29,000, 296,000,
Yep, I got that.
right?
Mhm.
And it's now what you should ask yourself is because the biggest thing here is finding the weight. Okay, so the weight of what? Are we looking for the weight of the models or the number of models or the weight of the price? Because that's going to affect what you divide by.
Oh, the price.
The the weighted mean, okay, so here, let me show you what happens. If you divide by, if you divide by the sum, now the prices have a sum of 20,000, yeah?
Right?
Okay, so if you divide by 20,000 here, you get 14.8.
Mhm.
Okay. If you divide by, you take this number here and you divide by the sum of the models that you got. I think you had 30, if I remember correctly, right? 8
Yeah.
plus, is it 30, isn't it?
Yes.
So if you take 296,000 and you divide by 30, you get this.
Yeah. I just saw what I did wrong. On the bottom, instead of putting the W's, I put the X's and I
Okay.
added up. That's how I got
That's-
30,000 on the
That's
bottom.
why I wanted to
That's
show
why I
you.
was, because I saw the answer. I was like, wait a minute, do I have
That-
to move this decimal? In my defense, I was super sleepy last night.
No problem, but that's a very common mistake to make, and that's why I wanted to show it here. So
Right.
when you're doing the weighted mean, okay, finding the weights is actually the hardest. It's an easy mistake to make.
Yeah.
Okay. So it's the weighted means of the models. So you're dividing by the number of models there are.
Mm-hmm.
Okay, so just something to remember there.
Yeah.
I'm not sure who's our third participant. I can see your name on the screen, but I don't know if it's a screen name. So can I help you with something? Let me type in the chat because maybe they stepped away from. Jason, how are you doing?
Okay, I put all the percentages, I divide them by 100 and times them by 360.
Right. Well, okay, so you don't have to. You can divide by 100 to get the decimal and multiply by 360 to get the degrees. Yes. And then you just put them in the pie chart.
Okay, so
Okay.
the first one I got was 90,
Mm-hmm.
75.5,
Uh-huh.
133.2.
Okay, hold on for a second. Let me put this up on the screen.
Okay, did I do anything wrong?
I don't think so, but I'm not looking at that part of the screen. So let me just roll back here and catch up with myself for a minute. You didn't do anything wrong, Jason. I just don't have 3 pairs of eyes. And so, but yeah, 90 is correct. 90, I remember the first percentage being 90, so I know that is a correct number. But let's see, you had, what did you, oops. 2.3 homework, there it is. Okay, so you had 25% of 360 is 90. 21% of 360 is about, yeah, that's about right. 37% of 360 should be slightly over 100, and it is. Okay, so you got all those percentages.
133.2.
Mm-hmm.
And then after that, it's for 9%. And then
Mhm.
for 9, it's 32.4. And then for
Mhm.
8, it's 28.8.
Okay, so that's good. So now that you have the percentages, it's just a matter of putting them in the circle. Okay,
Okay.
is that what you're having difficulty on, or was it just the conversions to the percentages?
Probably the percentage part. I could
Okay.
develop the
Okay.
pie chart
One
easily.
tip in doing the pie chart, because some people have asked me this, she's not very sticky on like being exact. So you do not have to use a protractor. If you have one, that's great, but you do not have to do that. If you're doing it by hand though, it's easiest to start with the biggest percentage you have and make a sector of the pie from that one and then work down.
Yeah.
Generally, that's an easier approach.
I actually found a way to make the circle. I use coasters.
Oh, nice.
Yeah.
Nice. Okay.
I also have another question.
Sure.
Is number 3 of 2.3 the similar to the second question?
Yes, those are all, if you look, and she left her percent sign off, but if you look, white is 19%. So
Mhm.
here you're given the percentage. So again, just divide it by 100. And then
All right.
multiply that by 360 to get your degrees. Okay?
Okay. Did it say that in the notes or?
Yes, if you look on the slide, there's, let me see if I have that open. Somebody asked me that too. You guys, the people who watch this on replay are gonna be so happy because you guys are hitting all the questions that everybody's been asking. So I don't know if you all saved them up or if you just all happen to think alike, but it's
Similar.
all happening. 2.3 other types of graphs. Let's take a look at this. Let me share the screen here. Am I sharing? No, I'm not, but I do have the PowerPoint open. That's a start. Except it doesn't. Okay, hold on. Give me a minute to move this around so I can. All right, I think we are. Maybe yes, maybe no. Not sure here. Let's see. View. Full screen. Shares. There it is. I had to manipulate my screen to let you guys be able to see the PowerPoints. Can you see them now?
Yes.
All right. So now this is where she talks about the percentages. Now, in this case, somebody asked me about this too. This is her example of where you've been given the pounds. Now, this is where, like the first problem that you did, okay? This is like the first problem. So what she said to do here, and this, but the math works out the same, is to convert to your percentages. So you take your category frequency over the total, and then you multiply that by 3. So what she did here, she basically did that, but she divided here by 360, but you can also do your category, because this 11.2 is really part of the numerator. So it doesn't really matter if you divide and then multiply by 360, it will come out the same, because this is being multiplied together. So that still worked. Okay. So
Also,
when you're doing the second and third one, you already have these percentages. Okay. So all you're doing here is multiplying the percentage by 360, because in effect, you've already done this part. You've already done this first part, and you're just multiplying the answer by 360. So the math works out the same.
also another thing, can we, since I already know how to do question 3, is okay if I could check on question 1?
Yeah, let me just, did you have another question, Giovanna? Or did I answer your question?
Oh, I had one more question on number 13. It's the same thing with the decimal point, except
Okay.
I'm like pretty sure I did the equation right, because I added up all my W's on the bottom, and I made sure it was my W's, and then I did all my multiplication on the top and everything.
Gotcha. Okay, so you it's the same idea as,
Yeah, it's the same idea, just different decimal place.
gotcha. I just need to switch screens. So let's see here. 3.1. And what number is that?
13.
13. Okay. Okay, so we're talking about the study of percentages of people who liked the weighted mean of the percentages, right?
Mm-hmm.
So again, you're going to multiply the percentage by the number surveyed, right? And then you're going to divide by the weighted mean of the percentages. Okay, so that means the denominator is going to be, the weights are the percentages. Okay, so, and you're having issues. What answer did you end up getting when you did that?
0.3542.
Okay, and you were supposed to get, okay, so yeah, so probably what happened was did you happen to use the whole numbers as the percentages? How did you do it?
So I did for area 1, I did 0.40 times 1000. And then I did plus 0.30 times 3000, and then I did plus 0.50 times 800.
And you divided by what?
And I divided by the total W, so I divided by 4,800.
Okay, now remember, find the weighted mean of what? Of the percentages. So your X's are the percentages. And your weights are the total, right?
I can't see your screen.
I'm sorry. Thank you for letting me know. So let's see. Thought I had taken care of that. Let's see if this, how about now? Is that
Yeah, I
okay?
can. Yep.
So, okay, I like your formula, right? Find
Mhm.
the weighted mean of the percentages, okay?
Mm-hmm.
Now, my hunch is that here, because you're only off by a decimal, my hunch here is she used the whole number. So try it with instead of 0.40, because that's already, see, this is already a percentage.
Okay.
Try it with that and see if it comes out, because you're only off by a factor of 100.
Mm.
Okay, so in this case, I think it's the way you treated the number, because if you use 0.4 in this case, this column is already in percent. Does that make sense?
Yeah. Yeah.
So you didn't need to convert this to a decimal. Does that
Okay. Yeah. Because
make
but I
sense to
thought,
you?
yeah, I understand, because I thought since it's percentage, I have to convert it to a
Right,
decimal.
right. No, and it's a little, yeah, that one is a little ambiguous in that way, but I think that's why. Try it and see if that.
Okay.
Where is our third participant? I thought this person was here and then they disappeared again. Is somebody here? Let's see. Oh no, he's here. Let me see if, but I don't see. Rola Gale. I'm sorry if I'm mispronouncing your
I'm right
name.
here. Yeah, I'm right here.
Can I help you with something?
Can you help me with 3.2 measures of variation?
Okay, what is it that you need help on? What is it that
Mm,
you're working on?
Number one.
Number one for that? Okay. Let's take a look here. Let me switch homeworks. 3.1. Okay. Okay, so here we are. Oops, I think this is 3.2. Am I wrong? Let me go to, maybe not. Oh no, we are. So it says, are salads a healthy menu choice? Listed
No,
below.
this is 3.1. I was talking about 3.2 measures of
3.2.
variation.
I'm sorry, my apologies.
What's up?
3.2. 3.2, I don't have open yet. But we will fix that. There it is. Does that look better? Maybe I need to share again. Did it show up? Oh,
Yeah,
it
it
showed up,
shows.
I think. 3.2, number one. Okay. What is the relay? Okay. So what do you basically here? What she's asking is, how are they related? So if I have the variance versus the standard deviation, what do you know about the variance versus the standard deviation?
Um, Not a lot.
Okay, well, it's in the slides. It's also in the textbook. So let's look at that now. Let me pull up the slides for 3.2 and I'll show you that. Because that, the comprehension questions generally come off of the slides. So they're not meant, or they come from the book if you're reading it. So if you look here, it says the standard deviation indicates how far on average data values are from the mean, right? And if you look down here on the second slide, look at this slide number 4. It says the variance is S squared and the standard deviation is S. So what that means is that if I have one of those, I can get the other one, okay? So if, let me annotate on the screen, if I'm given, or I have, let's say, the variance is 25, Okay. This is my variance. What is my standard deviation according to the slide here? My variance is 25 units. What would S be?
5.
Right. S is the square root of 25. So the answer to that is that you could say this a couple of ways. You could say that the standard deviation, S, is the square root of the variance, or you could say the variance, the standard deviation squared is the variance. So the standard deviation squared is the variance, or the variance is the square root of the standard deviation. So we normally would write something like this. S is equal to the square root of S squared, which I think she writes for you on one of the slides. You can also write that in words if you want. Okay, but that's where this is coming from. Okay. Let me see if I can help out Jason some more, but you're welcome to stick around and ask more questions as you see fit. What do you need help with in 2.3, Jason?
Just the first question, if I got it right.
Oh, you want to see? Okay, let's take a look. Let's go back to,
Because what I did was I
Uh-huh.
did the number and the percentage.
oh, you want to see? Okay, 2.3. All right, let's take a look here. So 2.3, you want to see if you got the percentages correct for that.
Yeah.
Okay, well, what did you get for your total?
For the total, the number, the sum is 1,000.
Okay. All right, so what did you get for the first percentage? Personal business.
0.146,
Perfect. Then
0.33,
perfect.
0.225,
Okay, and
and then 0.99.
0.299, right?
Yes.
Okay, good job. And then you know how to convert them to degrees now, right? So you just take that decimal and multiply it by 360. Okay.
Okay. Let me see. Oh. If 52.6.
Okay. Uh-huh.
6. And then 52.56.
Okay. So it's gonna be about that hundredth is gonna make a difference in terms of your total for your percentages, but it's not gonna make a huge difference in terms of drawing it out, right? So you're doing well there, okay? Because this, let me put it up. This is going to be, let me put this on the screen. So we have, for example, we have 146
Yep.
divided by 1,000, right? And that's going to give you, as you said, now if you multiply this by 360, you do indeed get 52 point. This is degrees now, right?
Uh-huh.
In practice, when you draw this out, like you're not going to be able to make too much of a distinction between 52.5 and 52.6, right? But
All right.
more than likely, you're not going to take this out to more than 2. I wouldn't think. But your total degrees should add up to 360. You might have to play with some of the decimals if they go out too far beyond that. But you're doing the right thing, Jason.
All right.
Good job.
1, 3, 3.
Okay.
Mhm,
Does
mhm.
anyone else have a question right now?
I had a question.
Yes, ma'am.
On homework 3.2 for 16 and 17.
3.2. Okay, somebody's getting a lot done here. Let's see. 3.2. Let's take a look here. We have, let me switch gears one more time here. 3.2. Oops, that's not what I wanted to see. Let me go back one more. There it is. You said 16. Let's take a
16
look.
and 17.
Oh, okay. So we get, okay. So have you guys had the lecture on Chebyshev's theorem yet?
We were supposed to, but she didn't go over it.
Right. I talked to her about it and she said she's going to come back to it at some point. So this will give me a chance. I have to do a little bit of teaching here, I think.
Well, I looked back at the PowerPoint and I took notes on it, so I
Okay.
understood how to do 13, 14, and 15.
Okay. But this one was a little bit, I
Yeah,
can
this
see,
one
Yeah.
was different. I got
I
stuck
can,
on
no, it is, and it is by design because Chebyshev's theorem can be different. So let me make sure that we're there. Okay, so now let me first of all, am I sharing the screen? I don't believe I am right now.
No.
Let me share it because I had to pull up the assignment first. All right, so here's 16. In a distribution of 160 values with a
Mhm.
mean of 72, at least 120 fall within the interval from 67 to 77. Okay. Approximately what percentage should fall in the interval from 62 to 82? Use Chebyshev's theorem. Okay. Now there's a lot of information packed into that. Okay. So in a distribution of 160 values with a mean of 72. So let me, what I usually do, and keep in mind, what's hard about Chebyshev's theorem is we don't know what the distribution actually looks like, okay? Could
Mhm.
be it's a normal bell-shaped curve. It could be very skewed, but what we're trying to get at is an estimate of the values. And because we don't know what shape it is, it tends to be a more conservative estimate. But for the sake of doing these problems, to help visualize this, you can draw a line like this, okay? And you can
Okay.
almost kind of visualize this as, so what is the mean? The mean is 120, right?
Yeah.
Is that what it said?
Yeah.
So we're gonna
Oh,
put the mean in the middle of this line. Just for
oh
this,
wait, it says in a distribution of 160 values with a mean of 72 and at least 120 fall
I
within
mean,
the
okay, I remember reading something about, my apologies. So the mean is 72, right?
Yeah.
And we know that there are 360 values, right? So there's a total of 360 values.
Oh, 160.
This is what I have you for. 160 values, okay? Let me go back for a minute. So what I'm doing here, I need to learn to take better notes. In a distribution of 160 values, with a mean of 72. At least 120 fall within the interval from 67 to 77. So what I'm going to do here is I'm going to say this. I'm going to go back to my whiteboard and I'm going to say, okay, there's somewhere over here. Now, I don't know how many standard deviations I am away from this mean,
Mm-hmm.
but I do know that 67 is less than 72,
Yeah.
right? Now, I don't know how many, I don't know how spread out this distribution is. Like, I don't know if they're one standard deviation apart or two or whatever, but I do know that 67 is over here.
Mm-hmm.
And I know that 77, I'm going to put it over here. And it's the same distance away, which doesn't always happen in these problems, but it happens to be the case here. This is 77 over here, right?
Yeah.
Now, the trick to this problem is we need some percentages to be able to figure this out, don't we?
Mm-hmm.
But we know something. We know that in this interval that I just drew, and I'm going to draw it, I'm going to use a different color on the line here. In this interval here, it's supposed to be different, and it's not. There it is. This interval has 120 values in it, right? At least. So I'm going to put 120 in here for reference. 120 values, right? So now let's think about this. What, I'm going to ask you a question here. So what percentage, and this you can get from the information they gave you, what percentage of the total number of values is between 67 and 77? What do we know about that? How would I find that out?
You find it out by doing 1 minus k to the power of 2.
Not yet, but we will. Because we don't know what k is yet.
Oh yeah.
Okay. But notice the question I asked you. What percentage of, how many total values do we have?
We have 160 values.
160 values. So what percentage of the 160 values is between the brackets?
40%.
Okay, tell me how you came up with that number.
I subtracted 120 from 160.
Okay, so what that tells me is that there's out here. Okay, so you did a thing and you answered a question, but that's not quite the question that I asked. The number that you found is the number of values here plus the number of values here in the purple.
Yeah.
So in the two purple zones together, there are 40 values.
Mm-hmm.
Okay, maybe there's 20 here, maybe there's 20 on the right, but there's 40 values. But that's not the question I asked. The question I asked is, what is the percentage of values here? Now, you know there's 120. So what if I ask the question this way? What if I say, I'm going to ask you the same question, but in different words. What percentage of 160 is 120.
Let me see.
See if you can come up with that for me.
$75%.
There you go. So what if I revise the question and say this? What if I say, a distribution, I'm going to rewrite the homework question for you. A distribution of 160 values has a mean of 72 and 75% of the values lie between 67 and 77. Okay. Now that's another way to state our information. You see where we've gotten from there?
Mhm.
Okay. So now that 75% is very important because Chebyshev's theorem, what does Chebyshev's theorem say?
Let me. It says that it like gives percentage of the spread in terms of standard deviation.
Right. So Chebyshev's theorem right here. Here it is. Slide number 20 in this section, right?
Mhm.
And we're looking for K, right?
Yeah.
But we have the percentage. So we're going to slip over here. And, oh, I thought she gave you the percentages to memorize, but I guess not on there. Not on this one anyway. Oh, it is, but she just, okay, I see it. So here it says, notice that when K is 2, the percentage is 75, right?
Yeah.
So that this 75 is important because now we know that we know this. We have to kind of back our way into this problem. We know that between the green area here, right? There are now K is 2 standard deviations from the mean, right?
Yeah.
So this here represents 2 standard deviations.
Yeah, because K2 is 75%.
Right. So 75% of the values lie between, so this distance here is 2 standard deviations is what we now know, right?
Yes.
K is 2, right?
Mhm.
Now we're almost there. We know K is 2, but we don't know what the standard deviation is,
Mhm.
but we can find out, right?
Yeah.
Because if this distance is 2 standard deviations here, right?
Mhm.
Then aren't I 1 standard deviation on either side?
Yeah.
Right? And how many units then is that? So in this case, that means that this is 1 standard deviation over here, right?
Yeah.
So what would that mean? And so now what we're asking for is, once we know that, the question says here, what number was that? It was, okay, what percentage should fall between 62 to 82? Okay, well, 62, how far is it from, let's look at this. How far is it from 62? So somewhere back here we have 62, right?
Yeah.
And we have 82 over here, don't we?
Mhm.
Now, keep in mind that we know something. In the original green brackets, let me do something here and erase. Go ahead. Do you have a question? Did I lose you somewhere?
What?
Did I lose you somewhere?
Oh no.
Okay, so here, now 62 to 82, how far is that apart? How far apart are 62 and 82? How far apart are 62 and 82? Well, that's not a trick question. How far apart are they?
They're like in standard deviation.
82 minus, well, let's do this first. 82 minus 62 is how much?
It's, hold on. 20.
20 units, right? We'll call it 20 units, right? Now, 20 units, and between 67 and 77, that's 10 units, right? Would you
Yeah.
agree? So basically what we're given here is, we know that 10. So let's go back to the slides for a second and I'll show you something. If you remember looking at the slides here, we did something where I have to see if she showed you that. I think she does. Right here, you see? The smallest value, so you're kind of doing what this is. So
Yeah.
you know where you ended up, right?
Mm-hmm.
And you know what K is, right? But you don't know what S is. That's essentially where you're at. You know what X bar is. You know what K is now. So here's what we're gonna do. So we're gonna say, we're gonna do this. We're gonna come over here on this part. We're gonna just hold on to 20 units for a sec. We're gonna get our standard deviation here, because remember I said you have everything you needed, right?
Yeah.
So we know that we ended up at, it doesn't matter if you do the left or the right, by the way. I'm gonna work on the right. 77 is equal to X bar, which is, so this is gonna be, this is my formula that I just showed you. So 77 here is equal to X bar. I can get, here we are, X bar plus K times the standard deviation, right? Because this is my mean plus this, right? K times the standard deviation. Now, I know what K is, right? How do I know what K is again?
Because we found the standard deviation for 67 to 77.
Right, we know that there's two standard deviations because the percentage is 75%,
Uh-huh.
right? So this is two standard deviations away. So if I say this, if I say, well, okay, then I say, all right, well, 77 is equal to 72, right? Plus K S. Now here, how many, now this is tricky because two standard deviations is the whole interval, right? So we have one on each side, isn't it?
Mm-hmm.
So we're gonna have 1 times S. Okay, because I'm going from the middle. 72 is equal to 1 standard deviation on this side times my,
Mm-hmm.
okay, so what is my S? Well, that means S is 5 units. Right? Now, how does that help?
Is it S is 5 units because 72 to 77 is 5?
That's right.
Okay.
Because this is 1 standard deviation,
Mm-hmm.
right? And this is another. There's 2 standard deviations between these. Does that make sense?
Yes.
Between these 2 numbers. And these numbers are on opposite sides of the mean. So there's 1 standard deviation over here. Okay. That's why drawing it out in a case like this, I think is a little helpful. So you can actually see it, right? 1 standard deviation here, 1 standard deviation here. So our standard deviation is 5. Now, how many, so what we want to know is, the question here is, what percentage lies between 62 and 82, right? Well, we know that's 20 units apart, right? So let's look at this here. So if we know that to be true, then here we're going to do our same little bit of math. You can start from either side. You can either start from the 82 and go back to 72, or you can go from 72 back to 62. Doesn't really make a difference. Pick one. I'll go on the left side this time since I went on the right side before. So here I'm going to say that 62 is equal to the mean, which is X bar, 72. But in this case, I'm not going to add because I'm going the other way. So minus K, right? And I know that my standard deviation is 5 units, right?
Yeah.
So here, what is my K here? This is 5 units. Go ahead. You'll get 62. So if you subtract 72 from both sides, right? We're going to subtract 72 from both sides, aren't we? So we end up with -10 at 72. We end up with -10 is equal to -5K. Right? And so what does K equal?
Wait, how did you get -5 then?
Because I know that S is 5 units,
Oh yeah. So okay, yeah.
right?
Yeah, because you have to subtract 5 to get to 67.
So here K is going to be 2, isn't it?
Two.
Because here. This
Oh
is
yeah,
what's,
because you divide.
yeah, because this is the middle, right?
Yes.
This is 62 or 72 rather. This is 72, right?
Yeah.
And we said that my standard deviation, think of it this way. So my standard deviation, we decided was 5 units, right?
Mm-hmm.
So count back by 5s. 72 minus 5 is 67, right? And 67 minus 5 is 62 units,
Mm-hmm.
right? So now we're 2 standard deviations away from the mean here, aren't we?
Yeah.
And if we go, we're gonna remember my standard deviation here, S, is 5 units. S is 5 units. And my K here, I'm showing you 2 is what I'm showing, right? So this is 72. I'm going to go up 5. That's going to give me 77, right? And if I go up 5 more units, that's going to be 82, isn't it?
Yeah.
So now, what is the percentage of values by Chebyshev's theorem? The one I told you we would get to that, right? So Chebyshev's theorem gives me this. This is 1 minus 1 over K squared. Let me put the square in there. This is 1 minus 1 over K squared, right?
Yeah.
Where K is 2 now, right?
Mm-hmm.
Well, if I've got, here's, that was what there's a 10 unit spread, there's another 10 unit spread here, right? So any spread of 10 units is gonna be, but we're looking at 62 to 82, aren't we?
Yeah.
So in this case, if we're looking at 62 to 82, we would be looking at how many intervals of the standard deviation? We have a total of 4 of those, right? So now your K is, so you have, and if you do the percentage there, I think it comes out to like 90, it's over 90%. I'm pretty, I don't remember the exact number, but I think it's 96 or so. Let me see what the actual percentage says. Yeah, 93.75. Because you'd end up with like 1/16 or something
Wait,
like
so
that.
how did you get 93.75 again?
Okay, because our K now, how many standard deviations are we away? We're 4, aren't we?
Yeah, because from 67 to 77 we're 2 standard deviations away. So
Right. So if K is 4 and you plug it in there, and go ahead and do the percentage for me.
okay.
Or Regali, what section is it that you need help on? 3.2 or 3.1? Let me see if she's, does that help you, Giovanna, or?
So I did hold on.
Oh, she left and came back. Okay, that's why. I was like, somebody left me a chat message, but wasn't here. Are you still working on that calculation? Or,
Okay,
hello?
I finished the calculation.
Did it work?
Yeah, I got 93.75.
Yeah, because K is 4 now.
Yeah, because it's an additional 2 standard deviations away.
Yes, there you go. Okay.
Okay, so what I had to do, I had to get my standard deviation first, and then I applied the other
Yes.
intervals, and then whatever my standard deviation is, added 2 more because each one was 1 standard deviation away.
Right. Basically, you're getting a new K in that situation. But the
Okay.
very first thing you had to do before that was find the percentage.
And then we got standard deviation, the S equals 5 because each number was 5
Because,
units away.
right, because remember we went from the mean to the n.
Right.
So the mean plus KS,
Mhm.
right?
Oh, okay. And number 17, is number 17 kind of like the same thing?
Let's take a peek. Yeah, except this time she gives you the percentage, but you need the range.
Yeah.
In
How do
which at least
I know to find the range, you have to subtract highest to lowest, but I don't think
in this case, she means the interval. So you're looking for an interval between this number and this other number. Between 27 and 38. She wants the interval, right? What is the 89? What does the 88.89 tell you?
80, it tells me that percentage of the data will, well,
Right. But what does that mean K is?
it means K is, I have to look at the PowerPoint.
That's fine. Go ahead. But it's in the slides. Tell me what K is when your P is that. Regali, are you here? I don't know if she's having problems with her internet connection or what. All right, let's see if I can help her out. I'll hang with you, Giovanna. Just let me know what you got, okay?
Okay.
3 point, let's see if I have this open. What? 3.2, number 4. She said. Okay. All right. Let me pull this down for folks. Let me actually, I'm not gonna step away. but-
K would equal 3.
Right, K is 3, right, so now, if K is 3, now I need to figure out, I'm 3 standard deviations away, K is 3, so what's S?
Let me see the problem again.
Sure, number 17.
Yeah.
So if the standard deviation is 32, find the range in which 80, so now this average. Okay, now you have to be a little bit careful, all right? Be a
Mhm.
little bit careful when you do this, because this is 3 hours. This is in hours. Your standard deviation is 32 minutes.
Mm-hmm.
Those have to be in the same unit. Be careful there, all right? So this one is a little tricky for that reason. So let me show you what we're doing here. Here we have, how many minutes is 3 hours?
90.
So the average is 3 hours. Right?
180 minutes.
That's right. The standard deviation is 180 minutes. 180 minutes. Now, I'm sorry, that's wrong. That is completely wrong. We'll just pretend I didn't say that. The mean, the average is 3 hours. The average is 3 hours, which is 180 minutes. That was correct. But
Okay.
what I said next was completely wrong. This is 180 minutes. Your standard deviation, it says, is 32. Okay.
Yeah.
Standard deviation is 32 minutes. Now, here's what's going on here. So we know that you've got 180 minutes here. This is 180,
Mhm.
right? With a standard deviation of 32. Now, how many standard deviations are we supposed to go back? Do you remember? What was your K?
The K was 3.
Right, so here's 180 minutes, right?
Yeah.
And we know that K is 3 when the percentage is 88.89, when P is 88.89, right? So we have to go back 3 standard deviations, right? So here's what
Yeah.
we're gonna do. We know that K is 3. We know that S is 32. Okay?
Mhm.
We don't know what our minimum is. We don't know what our minimum is here, and we don't know what our maximum is here. So this is a little more direct than the last problem that we did, because you already did the hard part. Okay, we don't know the
Mhm.
minimum, but that's what we want. We want the minimum and we want the maximum. Okay, we want the min and we want the max. So Can you think you can figure it out from there? Remember, you have a formula, right? So if you do the minimum, X minimum is going to give you, this is the mean minus KS. And X max is going to be the mean plus KX. So let's do the minimum together, okay? So the minimum is what? What is the mean here?
The mean is 180.
180. And what is the K?
The K is 3.
Right, minus 3. What is my standard deviation?
32 minutes.
32. That's right, so 32. So now do that calculation for me.
Okay. $84.
Right, so somewhere down here, 3 standard deviations back is 84, right?
Yeah.
84. Now, that's 3 standard deviations below the mean, right? Now I need you to find 3 standard deviations above the mean over here, right?
276.
Okay, so I could say that 88.89% of my data fall between what 2 numbers? 84 minutes and 276 minutes.
Yeah.
That's how you got that. Okay.
Yeah.
Does that make a little sense?
Yeah. I'm getting it.
This takes a little bit of this one is probably the hardest concept in the section to do. This
Yeah.
one's the hardest one.
I'll try 18 to see if I do it right.
Yeah. Let me see if I can. I might have to email this lady. And I feel bad because I don't know if she's waiting for me or if her internet connection drops. I'm not sure what's going on. But every time I go back to her, she's not there. And I know about number 4 because somebody emailed me about it already. So I want to get to her, but okay, let's see. Let me do it this way. You guys been keeping tabs on the YouTube channel? I know some of you guys are watching.
Yeah, that's how I was able to well, it was other YouTube videos I used, but
That's fine.
that's how I was able to do the equations.
No, that's okay. I haven't gotten to making the Chebyshev's one because I have to wait till she teaches it.
Oh yeah,
But
that's why it was a bit hard for me to grasp.
There will be a video on it. So I'll be putting something out with that. Look for that. But I know that for some of the others, if you had some issues with 3.2, for example, there's a whole video on one of those problems that somebody got into a big pickle with trying to solve. Let me see if I can find Regali's course. I'm not sure where she's from. Inbox. Mm. Mhm. Are you there? Mhm. Oh, maybe this one. Three point two.
So for 17, what was the range again? Was it 84 to 276?
276, if I,
Okay.
uh-huh. Let me just pull up the. There it is. And let me also pull up the YouTube chat while I'm here. 3.2, number 4. There it is. Click on that. Click on that. Control C. And go to.
I'm a bit stuck on 19. I made my number line already.
Give me 1 minute to finish this email.
Okay.
I want to email her because like I said, I don't know. Okay. Let me just. Yeah, this is being a bit slow. All right, so let me get back to you here. 19, you said?
Yes,
19?
yes.
All right, let's take a look at it. You'll be glad when we get out of this section, huh?
Yeah.
It's just really kicking you right now. Let's see what we've got. The average farm in the United States in 2004 contained 443 acres. The standard deviation is 42. Use Chebyshev's theorem to find the minimum percentage of data values that will fall in the range of 338 to 548 acres. Okay, this problem is kind of the reverse of the one you just did.
Yeah.
All right. So here she gives you the interval that she
Mhm.
wants. She gives you the standard deviation. Okay.
Yeah.
So maybe one way for you to kind of conceptualize this more, now that you kind of understand how it is, one way for you to make this a little more systematic would be to say something like this. So let me come back here and do this. Let's think about Hold on.
I can't see your screen.
No, it's coming. It's coming.
Okay.
I was just getting lost in all my screens. You didn't miss anything. One way for you to sort of make this a little more concrete when you're doing Chebyshev's theorem is there's only a certain number of things. There's a lot of different sort of variations of it, okay? But there's only a certain number of things that they can give you. So they can give you some kind of minimum, right?
Yeah.
Minimum interval. They can give you some sort of maximum, right?
Mhm.
Sometimes they give you more than one of these, like in that problem where we had, it was 67 to 77, and then they backed up and gave you a different one, but they'll give you some sort of interval, right? They can give you a percentage, okay? Or they can give you a standard deviation, okay?
Mhm.
Now, this is what's tricky. This standard deviation is S, okay?
Yeah.
So they can tell you what the standard deviation is, or they can give you some number of standard deviations. And this can either be K, or it can be K or K indirectly. Because it might give you a whole like a whole interval instead of just, remember, K goes from the mean to the mean plus the standard. So they can basically, they can give you K, they can give you S, they can give you P, they can give you the max, they can give you the min, okay? So there are 5 options. And you're always asked to find at least one of these. So let's look at the problem that you're trying to solve here. That's your headache of the moment right now. And see if we can make it less troublesome for you. So here's our number. The average farm contained 443 acres. This 443, what is that?
That's our median. I mean our
That's your
mean. I put that.
mean, right? Mhm.
Yeah.
The standard deviation is 42. Now, is that S or K?
That's S.
That's S, because it's not a number of standard deviations, it's how much each one is. So that's S. Now, so they've given you a mean, they've given you S. Now we want to find the minimum percentage of data. So we want to find P.
Yeah.
Right? And they've given us a range, 338 to 548. Okay, you see where this is going?
Yeah.
All right, so here, we're gonna do this. You have your number line, you said, so let's take a
Yeah.
look. Let's see what it looks like. 338. So we're gonna have something that looks like this. We're gonna have 338 on this side. 338. And what was it? 548, did I say?
Yes, 548.
548. And we said that our mean was what?
443.
443. So, okay, so here we are. And somewhere here we have 443, right? Okay, so now it really, we need K and we need S to find the percentage, right? Well, we know what S is because they told us.
Yeah.
Okay, so our minimum here is 338. Our maximum here is 548. Our percentage, we don't have. That's our question mark. Our standard deviation is 40, was it 42? Is that right?
Yeah, 42.
So S was 42. So we're looking for, we don't have K either.
Mhm.
Okay. So before we can get the percentage, we get K. All right. So you can either use the max or the minimum formula. So you can either use X max is equal to the mean. And I forgot to put the mean on this list. Mean plus K times S. Or you can use X min is equal to the mean minus KS. Okay.
Mhm.
It doesn't matter. You should still, but we want to get K first. All right. Because we know everything else. So what do you think we should do next?
Find like the distances between the mean and the maximum and the minimum.
You could do that, but the equation is going to help you. I'll show you that. So here the max is 548, right?
Yeah.
548. The mean is how much? 443. So that's 443 plus K times S, which we know is 42.
Mhm.
So there's basically what we're saying here is there's some number of multiples of 42 between these two numbers.
So I'm guessing what we do next is subtract 443 from both sides.
That would be very good. So then what do you get when you do that?
Let me search. 103.
Okay.
Or I mean 105.
105, that sounds better. 105, and that's equal to 42K, right?
Yeah.
So now let's divide that by 42. Now you might get a decimal. I'm not sure.
Yeah, I got 2.5.
So K here, and that's okay for K to be a decimal. K is 2.5. So there's 2.5 multiples here. Okay, of 42. K is 2.5. Now, you would get the same thing if you did for the minimum. So you only need to do one of these equations. Okay.
Mhm.
K is 2.5. So now, if I know what K is, now I can find the percentage, can't I? Because
Yeah.
isn't P is going to be greater than or equal to, right?
Mhm.
1 minus 1 over K squared. Okay. So if I look at this here, I'm going to have, this is going to be, I'm going to say that this is equal to 1 minus 1 over, and here, be a little bit careful, this is 2.5, and I'm going to square the 2.5, okay?
Uh-huh.
And I get 0.84. If I want to make that a percentage, it's going to be 84. Actually, it's going to be 0.84. If you want to do this, if you want to show the work, you're going to multiply this by 100. So this will be 84%. Now, there's nothing wrong with doing saying, okay, there's nothing wrong with saying, I have, between the two numbers, between 548 and 338,
Mhm.
and then dividing that by 42. But remember, K is from the mean to one of the endpoints.
Yeah.
Okay, so if you do it between the max and the min, you're gonna end up with twice K,
Mhm.
because you're gonna be on both sides. Okay,
Okay.
is that it for that one? Are you
Yeah.
good? How about 20?
I'm gonna work on 20 right now and see if I can get it right.
Okay, no problem. Now here, I will warn you, this is a bell-shaped curve.
Mm-hmm.
So this is where the empirical rule applies. You're not doing Chebyshev's theorem for 20.
Yeah.
You're doing the normal distribution for 20. Okay, so be careful there.
I am finish
Oh,
the degreeing for number 1.
okay, Jason.
Yes.
So you want to see what the circle looks like? Is that it?
Yeah.
And that was okay. I'm gonna have to pull up the book for that. Let me pull up the book here. I need to give me a minute to get out of my screens. There's a lot of screens open right now. Elementary statistics, there it is. No, then. Oh, I know what I need. I need this, but I need the other file. Let me go to look. Here it is. You're in 2 points. You're doing 2.3, correct?
Yes.
Yeah. Okay. Let me pull up the rule that on here. Pull up the appendix for you. So we're looking at somewhere data sets.
I finished the 3.2.
Did it work for you?
Yep, I got all the answers.
You got that one to work? Good job.
Yep. Thank
Nice
you.
job. You're welcome. That was quite the section, wasn't it?
I have to
Something.
go now. I have a driving lesson.
Oh, well, good luck. Stay safe out there. Okay.
Thank you.
Take care. We'll see you soon. Okay.
Okay. Do I need to type in my ID number?
I have it, but thank you
Okay.
for asking. I have it. I kept it.
Okay.
You're doing number. Okay, let me come back to, that's not the right section though, is it? You're doing the first pie chart. I need the one with 90 degrees in there. Review exercises. Why is, okay. let me take a look at something because 3.2. 2 point. Oh, maybe I was getting this mixed up with something. Let me see which one this is. Oh, okay. Personal, business, relatives, American, personal, business, work related, leisure. Got it. All right. So, personal, business, work related, or leisure now. Where is the book? Ah, here it is. Oops. I don't want to create one. I want to get out of here. All right. So I want to see where that problem was that we did. Even see it on here. I'm gonna have to look for the, okay, so let me just do it this way. So this is gonna be, I don't see the, did you take a picture of your work? Can you put it on the camera? 'Cause I don't have.
How do I
Maybe
put a
it's, you can take a screenshot if you're on a PC, you can use the Microsoft Windows key and print screen, or you can use your camera app and show me that way. I'm trying to see if I can find where 90, 32, this is not it. That's not it. I don't have, she must have taken it from somewhere else because I don't see anything. 90, okay. I'm gonna
Wait.
have to do it. What was that? Did you send it?
No, I think I saw it. Or
Is this, okay, so this is, let me make this larger so we can actually see something that we're looking at. This is the school grades, which I don't think that was the problem that you were trying
oh no,
to
it's
do.
the number of people traveling.
Yeah, no, I know. I think, let me see if I have it in the, I know where I might have it. Let me check something else. Because I thought she had put it there, but I think, let me check and see if I have it in my email from, have to dig it. Is there something else you had a question on as well, Jay?
No, just that.
Just that, okay, let me look for something really quick. This is section 2.3 circle, okay, 2.3 circle graph. Let me see if this is the one. Is this the one that she sent me? Okay, this is basically, this is a really gimpy version of it, but let me put this on the screen here. Because this will at least give you, forgive the art in here. So this was the, okay, so these were the numbers. So I had this was friends and relatives was 118.8
Mhm.
degrees. Leisure was 107.64. Personal was 52.56, and this was your 90. Work was your not 81 out of the total. Okay, so this was your roughly what your graph looks like. I think she changed a few of the percentages roughly, but it should look something like that.
Okay.
So let me see if she's still around, because I don't have the actual graph that it came from, but let me message her and see if she can send it really quick. Oops. No, that's not what to do. Sorry. Let's see if I can. Checkpoint 3 versus checkpoint 3. And sure. 2 point. The circle graph. This is 2.3. Number 2. Oh, I think it's number 10. That's why. 2.3. Number 1. Let me see if I got one, because I think this is number wrong. I think I think it's numbered wrong in the book. It's numbered differently. I mean, I know she numbered them differently, but I think it's also got, I think that's the one that has a mistake in it. If I remember, the book has a mistake. You don't have a mistake. You did
So-
fine.
So what do I put in the pie chart? The degrees or the percentage?
The degrees just tell you how big the sections are going to be. So like, let's do this. So you have a circle. The first percentage is, okay, let me see if I can draw a, okay, so we have a circle, right? And we're gonna, so one of your sections, I'm gonna draw some lines on the circle here. One of your sections is 25% or 90 degrees of the circle. All right. So you can either put, now the 90 degrees is just going to tell you how big the wedge is. That's all that's going to tell you. So this piece, that's 90, and it doesn't, did you put it, where did you put it? At the top or the bottom? Did you put it,
Put it like,
did you put it here? Or did you put it down here?
mine's is actually different. I don't know how I could show you unless I could send it to you by email.
Yeah, you can do that too. You can email it to
Okay.
me.
All right.
90 degrees is a quarter of a circle. So whether you put it, let me stop sharing here and pull up my email account. Exit full. So this is going to be, let me go here. Go to my inbox. That's my sent. My sent. My inbox. Which email did you send it to, Jason?
The one that has your name on it.
Oh,
At instructor.
The Gmail or the Canvas one? Okay. Sure, I can look at that. I just need to know which one it is.
Notifications at
Um,
instructor.com.
Oh, okay. So yeah, you sent it. Let me see if it's here. Because I have a message from. Okay, that's not it. I wonder if it went to. Okay, let me refresh this and see if maybe. It's not showing up in the Canvas inbox, but maybe it'll be in my. Maybe it'll be in my other. Let me see, Jason. Is it coming up that way? Let me see if the inbox shows me anything. It's not showing up there. That's weird. I wonder if it's being slow.
Should I send it again?
You can try. It's still refreshing my inbox. I'm gonna look to see if maybe it's. Sometimes it hangs, but it's doing well today. Okay, okay. I have announcement. I have. Okay, I have, no, I don't have that. That's weird. I wonder if it went to my, let me check something. And I wonder which account. Sometimes it does this. Sometimes it goes to my other account by mistake. But let me just check and see if I have a message here. It doesn't look like it, but that doesn't mean. Go ahead and send it again and see if, because it's not showing up in my.
I sent it to notifications at instructor.com.
Yeah, you sent it to my, yeah, no, that should be fine. It's just, it's not. You're sending it to the Canvas inbox, which is just fine. But the thing is it's not showing up
Oh, well,
as. It's not showing up in my inbox. That's a problem. Are you sending it from Canvas or through? I wonder.
through mail.
That's weird. that is very strange because, yeah, let me see.
What's your actual email?
Send it to, it's SMCKELLY
Hold on.
514. You want me to? Here,
Yes, put it in the chat, please.
I can, yeah, no worries. No problem.
Okay.
Let me put it there. Yeah, I'm not sure what's going on right now because it's been doing well, but maybe I jinxed it because I said that. Could be. All right, so here it comes. It's but let me make sure I'm sending it to everyone in the meeting. CK 4 at gmail.com. There it goes, Jason. Send it there and I'll take a look.
Okay.
Okay. Because now they're all open. So somebody should get it.
Mhm.
Refresh this. Because the last thing I see is her announcement, but unless it's blocking it.
All right. I just send it.
You just sent it and it's not coming. Okay, let me see. Jason. Yeah, I don't know what's happening with that. It's not here. Let me share the screen so you can see this. I have I have the announcements from but I don't have, let me see. Refresh the end, but there it is. Now it came. Wow, that took a minute. 29 and a half. 33, okay. This was, oh, this was for number, okay,
1.
okay. Well, what you sent me a picture of was number, oh, okay, I see. I gotcha. 146, yeah, that's okay.
Okay.
Yeah, that's fine.
So
That's fine. Mhm.
okay, and it's the percentages.
Yeah, you can, you don't have to put the number of degrees in there. The
Okay.
percentages and the description is fine. The degrees just tells you how big to make the wedge. So yeah, that's okay.
Also, another thing, when I put all the degrees together, it put in 370.
Well, in practice, you'd have to round this and play with the numbers a bit because it can't be more than 360, but the reason it's coming out like that is because of rounding issues. You know what I mean? Because if
Oh.
this is 0.295, so if you put in like, because these percentages are hard to, sometimes you have to fudge one or the, yeah, but it should, there's always 360 degrees in a circle. So,
Okay.
so it might look like there's 370, but this is 100% of the circle. So there have to be 360 degrees in it. Okay.
Okay.
So some of those decimals, like some of these decimals are less friendly, like the 330 is not too bad, but like the 146, that's a little unfriendly. That's 14.6 degrees. And the same thing here. This is 0.299, right? So, but they should add up, and you did it. They add up to 100%, right? That's where you want to be. Unless maybe, is that the only thing I can think of too is maybe that's, let me download it. If that was supposed to be a 29.4 and you have 29.6, but I think it's just a decimal rounding problem, but you're doing fine, Jason.
Okay.
Don't
So it's
stress.
correct?
Yeah, don't stress over that. You're
All
fine.
right.
You're doing well. Okay.
All right.
Anything else you want me to look at?
No, that's pretty much it.
That's it. All right. Thank you for your patience, my friend. I appreciate it.
Mhm. Yep.
All right. Well, we'll be back next week. Okay.
Okay.
If you have any questions over the weekend, feel free to, if you're having issues with the
With
Canvas
other-
inbox, just email me here. Email me using the Gmail address.
Oh, I thought you meant for like other questions.
Yeah. Yeah. If you have other questions, you can, I'll be looking at it throughout the weekend.
Like homework
Okay.
questions?
Yeah. If you have, we answer email on the weekend. We just don't
All
have,
right.
tutoring sessions on the weekends. But
All right.
we answer questions on the weekend. So if you're stuck, then. Okay.
All right.
All right,
Well,
Jason.
it's
Thank
nice
you
to
so
hear.
much.
All right. Thank you. Have a
You're
good night.
welcome. Bye now.
Bye now.
Recording.